Okay, so we have planes in space, so intersecting planes. So we can see here that we have plane A, B, and C, and A, E, and D. So we can see the both of them share point A there, so that's very important. So we have to determine the line of intersection between the two planes. So as you can see, the line of intersection has to run through A, so we already have 1 point on our line of intersection. So all we need to do now is take a horizontal cutting plane. So we can take it through E as long as it crosses, okay, horizontal cutting plane, as long as it crosses through the two planes. So we have E, 1, 2, and 3. So we can take them and find them in plan. So we drop down 3, okay, where it crosses AD, it's 3. We drop down 2, so where 2 hits a line AB, it's going to be 2. So make sure you label everything as you're going along. And drop down 1, where it crosses C to A is point 1. Okay, so the line E to 3 and line 1 to 2 touch each other, so we have to join them over here. So E to 3 and line 1 to 2. Okay, so where they cross will give you a point. Okay, it's a point on the line of intersection. So the point in LOI. Okay, so we have 1 point there, and we said already we have the other point on A. So we can join A through that point of intersection, okay, and draw in our line of intersection. So once we've that done, now remember, it's only where the two planes meet, so it doesn't go any further. It's only where they overlap each other. So now we have 1 point on the top here and 1 point on the bottom. And drop it up. Sorry, bring it up. There is point A, and then we can bring up this point, so it's on the line E to D. Yeah. So we're going to join them together. Okay, and very important now that you label it. So we have LOI, so the line of intersection. LOI, line of intersection. Okay, so determined line of intersection, that's part 1 done. So part 2 then, the dihedral angle between the two planes. Okay, so dihedral angle between two planes. So we know that we have to look at 90 degrees to get a true length. So 90 degrees, same thing, to get a true length. So we have to look at 90 degrees. Okay, or perpendicular to the line of intersection to get the true length, because we can only get the dihedral angle when we see a true length as a point view. Okay, so your adjustable set square is quite handy here. You can set it up parallel to your line of intersection. Okay, and then bring out your x1, y1. Okay, so we can bring it out here. Okay, so make sure you label everything. X1, Y1. Yeah, so we can just bring everything in using sliding set square because we've set it up. We can bring all our points up through that. Okay, so bring every point up. Okay, so the first thing we start with our line of intersection and put it into our, if we've projected an auxiliary From plan, it's an auxiliary elevation, so we have to take our heights from elevation. So go back, take our heights here. A. Okay, so that's point A. And there's our line of intersection from here to here. This is our line of intersection, but it's also a true length. Because any line that is parallel to the XY line is a true length in the opposite view. So you can see the line of intersection is parallel here, so it's a true length in this view. So now we just have to finish off our auxiliary elevation. So take all the heights across. So height C. C. And the height of E. D and D. So just bring all your points across using the heights. So we have A, the only thing we're missing is B. Okay, so we can join them back together. So A goes to B. B goes to C. And C goes to A. A goes to E, and D goes to E, and A goes to D. Okay, so now we have to look along the true length, okay, to get the dihedral angle. Okay, so you see the intersection of the planes. So sliding set square, or sorry, the adjustable set square would be a good one to use here. So set it up. Parallel. Okay, so I can rub out some of that line a bit far. Yeah. And set up our X2, Y2 line. Okay, so now we just use our adjustable set square to bring all our points down and make sure it's parallel with the line of intersection. Now we're projecting an auxiliary from elevation, so it is an auxiliary plan. So we always go back 2 views. So this is the view we're using. So go back 2 views and take the distance. So we take our distance from our XY line back to our plan. But that's quite a distance, so we can set up a measuring line or a datum line to relieve some of that distance. Okay, so it doesn't go way off the page on you. So set up a line parallel to your X1, Y1 until it touches the point D. That can be our measuring line. Anyway, so we have D is on the line, so we can find D straight away. Then we can start taking our points. So point C. Point D. B. Point A. So ABC and point D. Okay, so we should be able to join point, so A, B and C, and it should be a straight line. And then point, sorry, EAD is straight line, and ABC, they should both line up perfectly, like so. So we're looking at the edge view of the planes where they intersect each other, like that. So we need to find dihedral angle, so we're going to label it here. Okay, any of them angles will be the dihedral angle. So by labeling one, you are labeling them all. Okay, so make sure you label it as well, the dihedral angle. Okay, so that's as far as you need to go on that question. The projection of a line from point E and inclined at 30 degrees to the horizontal plane and 29 mil long and touches ABC. We'll do that in the next video. Okay, thank you.